In this lecture, we are going to discuss about logic gates, and we will be going to cover AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. So how we define a logic gate? Basically, the logic gate, that is the basic building block of any digital circuit or digital system. That means any of the complex digital circuit or system that consists simply of the logic gates. So basically the logic gates, they constitute a complete circuit. So they are considered to be the basic building block of any system, and usually the logic gates comprised of resistors, diodes and the transistors. So basically the analog electronic devices we used for the construction of logic gate. Later on we will see the complete circuit of logic gate. That means we will be going to discuss about how the logic gate consists of, what is inside the logic gate. But in this lecture I am just giving you the overview of logic gate, and later on we will see the complete circuit that consists of diodes and transistors. So in simple terms, a logic gate that is defined as electronically controlled switch, and the purpose of logic gate, that is to perform a certain logic function based on a certain combination of binary inputs. And what is the specification of any logic gate? Usually it is n cross 1. N cross 1 means there will be n number of inputs and there will be always one output. And usually the value of n we take, that can be minimum 2 or greater than 2. So we can say greater than or equal to 2. And the NOT gate, that is considered to be the exceptional gate that works on a single input. So total we have 7 logic gates: AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. So first gate is AND gate, and we will be going to discuss about the logical symbol. This is the Boolean expression, this is the truth table, and this is the logical statement. So we can see here, this is the logical symbol of AND gate, and for simplicity we are showing here all the gates with the two inputs. So let's assume that the input of this logic gate, that is A and B. Any of the variable you can think of, you can write here. Just put two variables for the two inputs. So we suppose the two inputs as A and B, and as I told you that the specification is n cross 1 with the minimum inputs 2. So we have taken two inputs, but always there will be one output. So output variable we are taking is P. So P is the output and A and B are input. This is the logical symbol. And here is the Boolean expression of AND gate. The Boolean expression tells the relation between output variable in terms of input variable. So what is the relation between output and input? That is P is equal to A dot B. So for the AND gate, we specify the Boolean expression as P is equal to A dot B. And here we can see the truth table of AND gate. The truth table basically describes the various combinations of input and the corresponding output based on the applied logic that is given by the Boolean expression. Like we have two inputs here, that is A and B. So in the binary, if there are two inputs, there will be four combinations. In general, we can say if there are n number of inputs to a logic gate, so there will be 2 raised to power n number of input combinations. So as n here is 2, so 2 raised to power 2 becomes 4. So we have 4 combinations of input: 0, 0, 0, 1, 1, 0 and 1, 1. And now we have to see the output of AND gate, that is specified as P. And for the AND gate, for the 0, 0 combination, 0 dot 0 will be 0, then 0 dot 1 will be also 0, and 1 dot 0 will be 0, and 1 dot 1 will be 1. So we have the output as 0, 0, 0 and 1. And what is the logical statement that defines the logic that is performed by this particular AND gate? So what is the logic performed by AND gate? We can see here, if all the inputs to the AND gate are 1, then only the output is 1. And in the rest cases, if any of the input is 0, like here this is 0, here this is 0, here both are 0. So if any of the input is 0 or all the inputs are 0, then output will be 0. So remember this point, very important, that in the AND gate the output is 1 if all the inputs to the AND gate are 1. For simplicity we have taken 2 inputs, but there can be n number of inputs. So condition is, if all the n number of inputs are 1, then only the output will be 1. And the one feature of AND gate we can see here, let's say if we are putting the B input as constant. So B input can be put constant as either 0 or 1. So first we put B as 0. If we put B as 0, so we see that the P will be 0. Irrespective of value of A, whatever the value of A we apply, that can be 0 or 1. It don't care about A. The output is simply 0 under the condition B is 0. So if B is equal to 0, then P is also 0. And in the another case, we can see that if we are putting B as constant, that is equal to 1. So in that case, if A is 0, P is 0, and if A is 1, P is 1. That means P copies A under the condition B is equal to 1. So if B is equal to 1, then P is equal to A. And second gate, that is the OR gate. This is the logical symbol of OR gate. Again we have taken 2 inputs A and B, and the output we are representing here R. And this is the Boolean expression that tells the relation between output and input. So R is equal to A plus B. And this is the truth table of OR gate. Again we have the 4 combinations of A and B, 0 0, 0 1, 1 0 and 1 1. And we can see here the output R for 0 0 combination it is 0, for 0 1 it is 1, for 1 0 it is 1, and for 1 1 it is 1. So what is the logical statement we can give here? What is the logic applied by this OR gate to get the output as R? That is, the output is 1 under the condition if any of the input is 1. Like we can see here, if B is 1, then R is 1. If A is 1, then also R is 1. And if both A and B are 1, then also R is 1. So what is the conclusion, or we can say logical statement? That is, the output is 1 if any of the inputs to the OR gate are 1. Then next we have NOT gate. So in the NOT gate, this is the logical symbol. And the logical symbol we have triangle followed by bubble sign. And input, I told you that NOT gate is the exceptional gate that is working on the single input. So input applied here, that is A, and the output here we are getting is V. So what is the relation between V and A? This is the Boolean expression, that is V is equal to complement of A. This is called as complement. Complement means A signal will be inverted. So if we are giving A as 0, we are getting V as 1, and if we give A as 1, we get V as 0. So what is the logical statement here? The output is 1 if the input to NOT gate is 0. So it is just inverting the input 0 to 1 and 1 to 0. So NOT gate is also called as inverter. So remember this point, the NOT gate is inverting the input signal, and that is working on a single input always. And the next is the NAND gate. This is the logical symbol of NAND gate. So we have seen the symbol of AND gate. This is similar to AND gate symbol followed by bubble. So NAND gate is the combination of 2 gates, that is AND gate and the NOT gate. So we have merged the 2 symbols, AND gate symbol and the bubble of NOT gate. So this becomes the symbol of NAND gate. And here A and B are input and Q is output. So what is the Boolean expression of NAND gate? The Boolean expression of AND gate we have seen, that is A dot B. So we are putting complement over it so that it becomes the Boolean expression of NAND gate. The AND gate Boolean expression with the complement over it. That is A dot B to the whole complement. That is the Boolean expression of NAND gate. And this is the truth table. We can see A and B are two inputs with the four combinations again, and Q is output here. So in the AND gate we have seen the output as 0, 0, 0, 1, and the NAND gate is the complement of AND gate. So here we get the output as 1, 1, 1 and 0. So here what we can see is, if B we are putting 0, so irrespective of A value, whether it can be 0 or 1, the Q we are getting is 1. And if we are putting B constant 1, then we are getting here A complement, that is 0 to 1 and 1 to 0. So if B is equal to 0, then Q is equal to 1, and if B is equal to 1, then Q is equal to A complement. And what is the logical statement here? In the NAND gate, the output is 1 under the condition if any of the input to NAND gate is 0. For example, we can see here B is 0, so we are getting 1. Here A is 0, so we are getting 1. Here both A and B are 0, then also we are getting 1. So what is the condition? That output will be 1 if any of the input or all the inputs to the NAND gate are 0. Then next is the NOR gate. This is the logical symbol of NOR gate. That is the OR gate symbol followed by bubble. That is the logical symbol of NOR gate. And in the Boolean expression we can see this is the Boolean expression of OR gate, that is A plus B. So here we have taken the complement of OR gate expression. So complement of A plus B, that is the Boolean expression of NOR gate. And this is the truth table. And truth table also we can see this is inverted OR gate. Like in the OR gate we are getting output as 0, 1, 1, 1. So here we get the output as 1, 0, 0. And what is the speciality of NOR gate? We can see here if we are putting B as 0. So here we are getting complement of A as S, like 0 to 1 and 1 to 0. And if we are putting B as 1, so irrespective of value of A, whether it can be 0 or it can be 1, S will be 0. And what is the logical statement? At what condition we are getting output 1? Under the condition if all the inputs to the NOR gate are 0. So if all the inputs are 0, then only the output will be 1. Otherwise, in any other case, if any of the input or all the inputs are 1, then output will be 0. Then next logic gate is the XOR gate. And this is the logical symbol of XOR gate. A and B are inputs and T is the output. And here the expression is A, then plus outlined by circle is the notation for XOR gate. So this is A XOR B, and the expression here is A complement B plus AB complement. The complemented variable A and the true variable B plus complemented variable becomes true variable, that is A complement to the A, and true variable B becomes complemented variable. So this is the Boolean expression A complement B plus AB complement. And this is the truth table. We can see A and B are having the four combinations 0, 0, 0, 1, 1, 0 and 1, 1, and the output here is 0, 1, 1, 0. So what is the logic behind this output here? That we have to see the number of ones in the input combination. Like for the first combination there is no 1. No 1 means number of ones are 0. And here we can see in the second combination we have only 1, 1. That is the odd value. Here also in the third combination we have 1, 1. So this is again the odd combination. And in the last case we have 2 ones, that is the even combination. So here we have even number of ones, that is 0. Here also we have even number of ones, that is 2. And in the second and third case we have single one, so that is the odd value. So conclusion is, for the odd number of ones in the input we get the output 1, and for the even number of ones, whether no one is there or 2 ones are there, the output here will be 0. So this is the logical statement that output is 1 if the number of ones as input to XOR gate are odd. And what is the speciality of XOR gate? Like if we put B is equal to 0, then what we get here? A is 0, T is 0, A is 1, T is 1. That means T copies A. And if we put B as 1, like in the second combination and in the fourth combination, B is 1. So if A is 0, T is 1, and if A is 1, T is 0, that means T is complementing A. So if B is equal to 0, T copies A, and if B is equal to 1, then T is complement of A. And this is the logical symbol of XNOR gate, that is the symbol of XOR gate followed by bubble. Output we are taking here is U, and this is the representation of XNOR gate, that is dot outlined with the circle, and here we have the Boolean expression, that is true value of A multiplied by true value of B plus complement of A multiplied by complement of B, that is A B plus A complement B complement. And this is the truth table of XNOR gate. Here we can see the U, that is the inverted output of XOR gate. There we were getting output as 0 1 1 0, and here we are getting 1 0 0 and 1. So what is the logical statement here? The output is 1 if the number of ones as input to XNOR gate are even, the vice versa of XOR gate. And what is the speciality of XNOR gate? Like if B we are putting 0, then we are getting U as A complement. It is 1, here it is 0, here it is 0, here it is 1. And if B we are putting 1, then U we are getting same as A. So U copies A under the condition if B is equal to 1. So this is the summary of all the symbols of logic gate. This is AND gate, OR gate, NOT gate. NAND gate we can see resembling with the AND gate followed by bubble. The NOR gate that resembles with the OR gate followed by bubble here. And this is the symbol of XOR gate. And in the symbol of XNOR gate, that is similar to XOR gate followed by bubble. And if we see the relation between P and Q, this is for AND gate, this is for NAND gate. So Q is inverted P we can say. And if we see the relation between NOR gate and OR gate, here output is S, here output is R. So S is complemented R. And what is the relation between XOR and XNOR gate? They are also complementary. The output here is T, output here is U. So U is complement of T. So we can see P and Q are complementary. If P is 1, Q will be 0. R and S are also complementary, and T and U are also complementary. So this is a summary of truth table, like 0 0 0 1. This is for the AND gate output, 1 1 1 and 0. This is for the NAND gate. The complement of P, that is Q, we are getting 0 to 1, 0 to 1, 0 to 1 and 1 to 0. Then this R is the output of OR gate, 0 triple 1, and S is the complementary of OR gate, that is NOR gate, 0 to 1, 1 to 0, 1 to 0 and 1 to 0. Then T is the output of XOR gate, 0 1 1 0, and U is complementary T, that is 0 to 1, 1 to 0, 1 to 0 and 0 to 1. So these are all the logical symbols, and this is a summary of the truth table of all the logic gates. And these are the references I have used. Thank you.